We are now going to commence our study of the four major chart projections used in aviation. It is a necessary condition of navigation that the angles shown on a chart are the same as the angles on the Earth. This property is known as orthomorphism, or conformality, and most projections in general use are not orthomorphic. However, four projections which are orthomorphic and are widely used in aviation are the Mercator, the Lambert's conformal, the polar stereographic, and the transverse and oblique Mercators. Our approach in considering all of these will be first to show the requirement for the chart projection, why is it used, then to establish the principle of its construction, and then to discuss its properties. We shall look at the same set of properties in all of these charts and see how they differ from projection to projection. The properties that we will examine when comparing the four types of chart projection will be the scale, where it is correct and how it varies over the chart, whether it is orthomorphic, the appearance of the graticule, are meridians of longitude and parallels of latitude straight or curved, are they parallel or divergent, and so on, whether the projection distorts shapes, and if so, how, the chart convergence. You will learn that this is not the same thing as Earth convergence. And finally, the appearance of rhumb lines, circles. We will now examine the Mercator chart projection in more detail. The Mercator chart is historically important because it was the first ever orthomorphic projection. It is also in common practical use today. Jeppesen used Mercators for en route charts in equatorial regions. On a spherical Earth, such as a globe, or the real Earth, the meridians converge. However, when transferring this three-dimensional situation to a two-dimensional representation, a flat sheet of paper, there are advantages to be gained in drawing them parallel. Euclid showed, over 2,300 years ago, that where parallel lines are crossed by a straight line, the corresponding angles have to be the same. Therefore, if a chart is drawn with parallel meridians, joining the departure and destination points by a straight line track gives a constant track direction. In other words, a rhumb line track. As we know, with modern computer technology, such as a flight management system, aircraft can be steered along great circle tracks, which give the shortest route distance. Unfortunately, the track direction changes continuously, and the computer has to constantly update the required track in flight. This great circle tracking technology became available only after about 1970. Before that, navigation was by compass, which required the aircraft to be steered in constant directions for long periods. The Mercator chart was the first chart which allowed this to be done correctly. Map makers had produced charts with parallel meridians before, but were not able to solve the problem of making the direction on the map the same as the direction on the Earth. The Mercator chart was the first ever chart which showed rhumb lines as straight lines, and was also orthomorphic.